Okay, so we're going to talk about 5.4 special solutions. This is kind of a throwback to Unit 1. Remember how there were two special solutions there? They were no solution and infinite solutions. And you've kind of seen those in Get More Math so far with like, the graphs and a little bit of your answers here or there. So we're just kind of gonna refresh that a little bit and more definitively talk about what method to use when. So let's look at this first one. Whenever you have two equations that are both solved for y, sorry, remember that's slope-intercept form. That should be a big indicator that you should graph them. Whenever y is alone, or both of them have y alone, that should be a big indicator to put these on the graph. So I'm going to graph the first one. So we start at -4. And then remember it's 5/1. So we go up 5/1, up 5/1. Can't go up and over, so I go down. Okay, and then there's my line, if it stays. Okay, then we do the next one. So we start at +2, and it has the same slope. So did you notice that both of them have 5? So when they have the same slope, that means they're never going to cross. They're never going to be able to touch each other because they're increasing or decreasing at the same rate. So in this case, when the graphs never cross, my answer is no solution. You might see it as no shared points on Get More Math. So it's really no solution with we draw the circle with the line through it, but on Get More Math, it'll say no shared points. And again, we knew to graph these because they both started with y equals. That's why I did that. Looking at this one, I see no variables isolated. So that tells me I should probably use elimination. But in order to use elimination, they have to be the same number, but opposite signs. So they need same number, opposite signs to use elimination. So we have to get either these x's to be the same or my y's to be the same. So I'm going to focus on my x's first. So I'm going to turn this 1 into a 2 by multiplying this bottom by 2. And that's going to give me -2x plus 8y equals 20. So now I can pretty much ignore this in the middle. I have the same number, but opposite signs here. So I'm just going to add up my equations. 2 minus 2, my x's cancel. But what else do you notice? My y's are the same number too, and opposite signs, so they cancel. I'm not left with nothing. We just said 2 minus 2 or 8 minus 8. In your head, hopefully you're thinking is 0. And then 20 minus 12 is 8. Is 0 equal to 8? No, so it's no solution. So circle with the line through it. Again, we got this 0. This 0 came because 2 minus 2 is 0. 8 minus 8 is 0. So they're both 0, so we can just put a 1. Okay? This last one has a y by itself. So we're thinking, should I be graphing? Well, only one of them has y by itself. So if one variable is isolated, that should tell me to use substitution. Okay, so we're going to take what y is equal to, this whole thing, and plug it in for y, because that's what it tells us to do. So our equation says for whatever y is equal to, in this case, 3x plus 1, equals the rest of the problem, 12x plus 3. And now I solve and distribute. So if you know how to solve and all that stuff, just pause the video. Otherwise, I'm just going to keep on going. 4 times 3 is 12. 4 times 1 is 4. 12x plus 3. Now we have variables on both sides, so I have to move my 12s to the other side. And the opposite of a positive is a negative. So those x's cancel. I'm left with 4. Those x's cancel. I'm left with 3. Is 4 equal to 3? No, it's not. So it's no solution. Or a circle with a line through it. Okay? So that's when you get no solution. Let's talk about infinite solutions. So in this case, I'm kind of forcing you to graph, but I would probably only graph if both of these are set equal to y. Otherwise, I'd use some other method. But since there's a graph here, we're gonna graph it. So in order to graph this y has to be alone. So how can I get rid of this 2? Well, I can get rid of the 2 by dividing everything by 2. So I'm gonna get y equals, there's a 1 here. 1 isn't divisible by 2. So I write 1/2 x. 2 divided by 2 is 1. So then I have those two things. What do you notice about these equations? What do you notice about these equations? Hopefully you notice that they're identical. Hopefully you notice that they're the same. So let's start by graphing the top one. So I'm going to graph this one. So I'm going to start at +1, go up 1 over 2. That's not over 2. Draw my line. All those points. Okay? Now I'm going to do the second one in blue. I start, oh, look at that, at the same point. And look, it's the same slope because it's the same equation. So if your graphs are on top of each other, they're the exact same line. How many points do they share? How many times do they intersect? They cross every single time. So they have infinite solutions. Or you might see infinitely many points on to get more math. Infinite solutions is the answer I'm looking for, or the infinity sign, either one. Let's go to the next one. So I'm looking at this next one. I have nothing solved. So we are just going to use elimination. And I'm looking for my x's to be the same number or my y's to be the same number, but opposite signs. So since that's the case, I'm just going to add these up. 7 minus 7 is 0. 3 minus 3 is 0. 14 minus 14 is 0. Is 0 equal to 0? Well, I know that's true. So my answer is infinite solutions. Okay. And again, I used elimination because both of these, well, this was the same number and opposite signs. Looking at this last one, I'm going to use substitution because there's just one variable solved. So I'm going to plug this whole thing in for x. So my equation says 2 parentheses my x value, which is this. So I'm going to write y plus 5 equals the rest of this. So 2y plus 10. I'm going to solve. 2 times y is 2y. 2 times 5 is 10. Wow, look at that. They're identical. But let's keep on going. Minus 2y. My y's cancel. Is 10 equal to 10? You betcha. So it's infinite solutions. So it's just showing you each way how it'll look. Pretty much if you get the same number at the end, it's infinite. If you get opposite signs, it's no solution. If your graph never crosses, it's no solution. If they're the same exact equation, they're infinite. So that's the only thing we're adding. We're not really adding anything crazy or new. So get trying on that homework and see how it goes.